Okay, I don't know if this is going to work or not, but let's give it a shot. Alright, so I'm doing a recording here where I'm writing a function. It needs to be a recursive function. Let's go ahead and maybe change this to be an arrow function equals. Okay, there we go. I don't know if this has any inputs. Let's see. Write a function which accepts a base and an exponent. Okay, so it accepts the base and an exponent. We can do b and e. The function should return the power of the base to the exponent. It should mimic the functionality of math.pow. Don't worry about negative bases and exponents. I'm guessing we also do not need to worry about anything besides integer exponents. We don't want to do irrational or fractional exponents. Yeah, I don't think we're going to be working on those. So we're going to assume that e, the exponent, is a positive or zero-valued integer. Alright, and the base is going to be some positive value as well. Okay, well then, let's see what we can do. We need to recursively make it so that we are returning the value of the base to the power. Okay, so we need to consider a stopping point. So let's see, we're going to stop where where the exponent is equal to 0. I think that's what we're going to have as our stopping point. So if e is equal to 0, return 1. And so this is good so far, I believe, because if that is the case right off the bat, if e is originally a 0 in the input, then we're immediately going to go into this condition and we will have a return value of 1, which is what we want because anything raised to the 0 power should be getting us back to being a 1. So that's nice. Okay, so now if we don't have an exponent being originally equal to 1, that means that we have something like 4 to the second power, or 4 to the third power, or 2 to the fifth power, something like that. And so what we want to do is we want to multiply the base by itself that many times. And so I'm thinking we do a return of power with the same base and e minus 1. And maybe we need to do b times that. That seems reasonable. So I'd be doing the base times the same function, the power function being called again on that same base and e minus 1, and I think that might do the job. I think that this will, like, say that the exponent is a 2. Well then, and let's say that the base is a 3, so 3 squared is what we are doing, and so we should expect to get a 9. Well, let's see if that would happen. Well, if we have this, we're going to skip this condition because e is 2, so that will not trigger. So we'll be down here, we'll have a 3 times our function being called with a exponent that is 1 less, and so that'll be a 1 because e was originally a 2, and now we are back into our function. We're going to again skip this condition because e is a 1, not a 0 yet. So we're going to get down to here. The base is still 3, and so we'll have another copy of 3 getting multiplied by another third call of our power function, but now e is a 0. So this will return us a 1, which will trigger the other 2 copies of the base getting multiplied by each other, which will turn into 3 times 3, and that will get us what we're trying to get. So let's see, do I need anything else? I don't know if I do. Let's try this. Test cases. We passed the test. Okay. Okay, so I think it's working. Let's do a just console log of our